Hey, what's up, YouTube fans? So what I wanted to talk about in this video, right, is why is it, right, that certain groups of living things, right, they undergo much more evolutionary change in terms of their body, various features. They undergo much more evolutionary change within a period of time, right, than other groups within the same period of time. This is something that's frequently brought up by those who are looking to try to poke holes in the theory of evolution, and also by some people that are just new to it and are trying to better learn and understand it. But so there's actually a few very good reasons for why this is the case. So there's actually a term for it called evolutionary stasis, when a group will, for a long period of time, they'll undergo relatively little evolutionary change. Even over hundreds of millions of years, they'll undergo relatively little evolutionary change. Not that they undergo no evolutionary change, mind you, but by comparison to some other groups which undergo vastly more change, right? Some groups will undergo relatively little change, right? And so why is that? What's important to understand, right? A few things. So differing groups will evolve differently based on differing environmental pressures. Some living things live in the trees, some in the water, some go in the air. And there's differing weather, differing predators. And so differing living things in differing environments will have differing environmental pressures, and therefore what's advantageous for one group will not always be advantageous for another group. Differing groups adapt differently, right? And then not only that, right, but then it isn't inherently advantageous to change, right? To change is not inherently in of itself always advantageous. Sometimes the way that a group of living things already is the most advantageous way for them to be, right? It's not always inherently advantageous to change more. And for some groups, due to the differing environmental pressures of differing groups, for some groups, it's much more advantageous for them to undergo more overall change than for others. And so that's not all, but this is what's more. Differing groups of living things have differing mutation rates, right? So mutation rates are the frequency of how commonly mutations occur within a species, right? And they can differ significantly between differing groups of living things. And not only that, but the mutation rate itself can change through the course of evolution, right? Based on the differing needs of differing groups, right? Because you see, there are differing inheritable variations which can in of themselves make a living thing more likely to have more mutations or less likely, right? And so the mutation rate can itself change based on the differing needs of differing groups, right? So for some groups like sharks, for example, which actually have the lowest mutation rate of all living vertebrates, sharks do, right? For them, that is the advantageous way to be. That was advantageous for them, right? Because of their needs, right, where they were in less need of undergoing changes, right? And so for some groups that are already the way that they are already is mostly good, right? It could be disadvantageous to have a high mutation rate, because not only is the way that they already are mostly good, but then there are also many mutations that are deleterious. It's not like all mutations are beneficial. Many mutations are deleterious, right? Whereas for other groups that are in desperate need of more mutations, because, for example, some groups of living things will be in an environment that happens to be undergoing a lot of change, right? Their environment is changing, and so therefore they're in need of adapting and changing, right? Because now their environment is different, right? So it will be helpful for them to in turn also change to match the new pressures of their environment. Then for groups like that, to have a higher mutation rate could be in of itself advantageous, right? And so based on the differing needs of differing groups will have differing mutation rates. And that, of course, significantly affects the amount of evolutionary change that they undergo, right? Because mutations are one of the main sources of genetic variation within species, right? And so therefore, the mutation rate of a species significantly affects the amount of evolutionary change that they will undergo, right? Also worth noting is that certain groups reproduce faster than others, right? So like for us humans, we typically, it typically, for a human, it takes decades before they, after a human is born, for them to go on to make another human, it takes decades, right? Whereas for other things, it could take, just like weeks or days, right? Before they go on to make offspring after themselves, first being produced, right? And so therefore, if they're reproducing faster, then obviously that's going to allow for them to adapt faster, to evolve faster, right? Because when we're talking about evolution, we're talking about changes to the percentage of organisms within a population that have various inheritable traits from one generation to the next, right? So if a species goes from one generation to the next quicker, then that's obviously going to have an effect on how quickly they undergo evolutionary change, right? And so, it actually isn't really all that confusing when you understand these things, why it would be that certain groups would undergo much more evolutionary change within the same time period compared to other groups. Also worth noting is not only can the mutation rate itself be changed through the course of evolution, but then also even certain regions of the genome can begin to have a lower or higher mutation rate based on the differing needs for a species. So, certain parts that, they would be best off just to mostly keep the same, and that it could be very disadvantageous to change it such as, the heart, for example. In the case of the heart, it would, for some groups, not necessarily be too good generally to have mutations to it because it's a vital organ, right? And so that could lead to a lower mutation rate for something like the heart, for some groups, right? Whereas if there's other parts of the body that they're more so in need of change, right, and would benefit from change, right, then there can be a higher mutation rate. And that itself can come about through the course of their adaptation, right? And these things are actually part of what's actually been sometimes termed as the evolution of evolvability, right? Because they're actually through the species, in instances like this, species are through the course of their evolution changing in ways that make their evolution in of itself run more efficiently, so to say, right? And so it sometimes has been termed as the evolution of evolvability. This, among other things, is not the only thing that's called the evolution of evolvability, right? But basically when species, through the course of evolution, change in ways that in of itself makes their evolution run more efficiently in the future. Efficiently meaning like in a way that's better towards them adapting, in a way that's evolutionarily advantageous, right? Then this can be called the evolution of evolvability. So, all right, that's all for now. See you guys.